Hello and welcome. Thank you for witnessing a step toward digital transformation. This time we present the first challenge of the SCADA Industrial Controllers course, programming a buffer station in ladder language of Rowell PLCs and its subsequent implementation in a digital twin with help of Factory IO software was performed.
Our team is formed by Javier Guzmán, Gustavo Vargas, and Camilo Paredes, upcoming mechanical engineers from Universidad Nacional de Colombia. As we can see in the video, the stage has two conveyor belts interrupted by a programmed blade in order to count and separate the boxes for applications within a production line.
Hi, my name is Javier Guzmán and I'm going to show you how the industrial software works for this activity. At the first step, we have to create the variables that we can relate with the physical actuators or sensors that are in our physical machine. With this, we define an algorithm that make some steps that are downloaded in a virtual PLC. In this case, is Studio 5000. We may make the download in order to check if our code is good structured, right? And with this, we can make some changes and evaluate how the signals are working, right? In this case, it takes a bit seconds, and when we finalize the download, we have to check if this point is setting as remote. When it is in remote, we can associate this software and this software with Factory IO that my mate will show you in the next step of this presentation. Thanks.
Hi, I am Gustavo. As Javier said, we download the Logix into the CPU card, and after this we can go to the Factory IO. We have to establish an OPC connection. This in order to connect our Logix emulate with the Factory IO. I mean the studio with the Factory IO. This allows to see the controller tags created in the studio and connect this with the sensor and actuators in the Factory IO. We can go to the control panel and start the simulation. In the display, we are showing the number of boxes that are in the conveyors. Since the first box appears, you can stop the simulation and start again. After the first box passes the first conveyor, the stop blade activates, and after the second box abandons the second conveyor, the simulation starts again.
In addition to the skills achieved by successfully completing the project, we highlight three conclusions. The advantage of industrial automation are enhanced by use of digital twins, avoiding field tests and reducing their cost. the implementation of industrial automation is enhanced given the powerful technologies available today. Finally, the scope of these technologies are within reach of the country's industry, and their implementation promises an upcoming digital transformation.